Okay, let's summarize what we discovered on our activity for our properties of our logs. Let's start with our first one here, our log base b of x times y. Multiplying our logs would be the same as adding them. Okay, so we would do this. So log base b of x times y is the same as log base b of x plus log base b of y. So the log of a product is the same as the sum of the logs. So multiplication inside a log changes to what? Addition. Addition. Okay? You're going to see some vocabulary. They'll say condense the logs, write them as a single log, expand the log. Okay, this is what they're referring to. As a single log, that's the multiplication that has been brought together. Expanding it, expanding the logs or something like that. In this case would be breaking them into the addition. Okay, so be looking for those vocabulary words that you, and this is kind of what they're referring to. You're going to go back and forth on these. All right, let's look at our next one. We have log base b of x divided by y. That would be the same as if we split them. Log
of x, the
minus log base b of y. So the quotient, the log of a quotient is the same as the difference. Thank you. It's the same as the difference of the logs of the numbers. Okay? So division inside the log changes to subtraction. Our next one, this was the bottom one, the third one that you looked at. What did we end up doing to that power? What did you do? That 0.7. What did you do with it? You multiplied it, right? You multiplied it. So here's what we're going to do with this one. Your p, the power. The power comes to the outside and he lands in front of the log. So he goes from being a power and he goes to the front of the log and he becomes a multiplier. Okay? So right now he's up here, right? He's up here as a power. When we rewrite him, he comes to the front and becomes the multiplier, right? Because if I have a power and I raise it to a power, what is a log? The log is the exponent. So, right? So I'm essentially taking a power and raising it to a power. What do? We multiply. So remember the log is a power. So we will move him to the front and it now becomes p times the log base b of x. Little elongated p and l in it. Okay. The log of a number raised to a power, right? But a log is a power, right? Power to a power is the same as the multiplier. So we'll say same as multiplier. Or we could say times. Okay? Multiplier or times the log of the number. Like times better? Do times then. Let's line up. Okay, so a power inside the log changes to what on the outside? what did he do? Multi. Changes to multiplication on the outside. That one's a little bit harder to understand or see. But it is this process right here, because you have to remember the fact that the log is the exponent. If you're taking the log and you're raising it to a power, you're essentially taking a power and raising it to a power. That is the same as multiplying them together. Okay? All right, we talk about the relationship between the exponential function and the log function. They're inverses of each other, right? And we talked about that earlier, about, where is it? If we put one inside the other, we compose them, we get back what we put in, and we just get back the x. So that is this one right here, okay? If I have log base b of b raised to a power, these are inverses of each other, and they cancel each other out. So my log base b cancels out the base b, and all I have left is the power. Okay? And you kind of did that on your little warm-up. That's kind of what they wanted you to discover on the warm-up. I told you we'd see that again. And that's it right here. And then this one, you also did this on your warm-up as well. Log base b of b. Well, if I have a base b and I ended up with a b for my answer, what was my power? 1. No, because if it was, yeah. Because your base is changed.
So b and log b cancel out.
All right, if we take a look at E, separately it's addition, so we bring them together as what? Multiplication. So this would be log of 10. All right, F, separately it is subtraction, together it is division. So this is log of 100. We can go ahead and divide that, and we can get 100. Subtraction again. So again, this would be what? Division. All right, I want to point something out. Please keep your subscripts. Please keep everything in order. You still need to have the log. You still need to have the base when you bring that combination. So be real careful when you're doing that. So, and if this is subtraction. You're subtracting the x from, the x is first, however, and you're subtracting the 10. So it comes out as x divided by 10. Okay? Now, H, this is where you guys got lost. This is being multiplied, right? When we're multiplying exponents, that's that power to a power property. That's this one working over here. That's this one working, right? And that's the example here. So I've got to take my multiplier of 2, and I've got to turn it back into a what? Exponent. So this would be log base 3 of x plus 1 raised to the second power. Okay? And you could go ahead and FOIL that out, and you could multiply that to get that quadratic back. We won't do it now, but you can, yes. You could go ahead and work that a little bit further. We could simplify that one a little bit further. And then again, you've got a multiplier here, so you're going to rewrite him, put him back into the log by making him a, what again? Exponent. So this would be log, this is a common log, so log base 10 of 2m to the 4th raised to the 3rd power. This one you can go ahead and multiply out. Some of you did. I'm going to go ahead and do it this time. So I am taking 2m to the 4th, raising it to the 3rd power. So I need to raise the 2 to the 3rd power. 2 to the 3rd power is 2 to the 3rd power?
8.
And what about m to the 4th raised to the 3rd power? 12. 2 times 2 times 2 times 2. Mm-hmm. Yeah, you're kind of distributing it like you distribute a number outside parentheses. It's the same kind of concept. Okay? Okay, our first one here, we have log base 5 of 5 to the 7th power. I have some inverses working here, don't I? I have a log base 5 and then another base 5. So by my inverse, I know those will cancel. And what do I have left? 7. Our next one, I have log base 6 of 6. What did I raise? 1. I raised 6 to a power of 1 to get 6, right? Log base 10 of 10 to the negative 4. Let's look at that. That's log, what's the base of this one? 10. This is your common log. Be very careful on these. Log base 10 of 10 to the negative 4.
1 over 4.
So here's my inverses kicking in. I know this log base 10 cancels this base. Yes. And all I have left is my power.
Do you put it in a... Oh, you don't put it. We did so actually.
No, we'll just get, the negative 4. That's it. That's all we have. Okay. All right. I see some addition. Are my bases the same? Yes. So can I bring them together as a single? Yes. All right, I'm going to do that then. So I have log base 12. I have 3 plus 4 separately, but together that would be 3 times 4. So that would give me log base 12 of 12. Can I do something with that? Yes, very good. Yes. What's my power that I raised 12 to? It is 1. So my answer is 1. Okay? Any questions on any of those? All right.